Hello everyone, it's Mr. Bowman. I want to do a quick review of linear transformations on random variables before we start talking about combining random variables. So linear transformations to a random variable x simply mean that we multiply x by some constant and we add some constant to x. As you know, adding a constant to all the values in a distribution or to a random variable changes the mean in that same way. Also, multiplying by a constant changes the mean in the same way. So, in other words, if the mean of the random variable x is mu subscript x, then we transform the random variable x by multiplying by b and adding a. Our new mean, mu y, is going to be equal to a plus b times mu x. In other words, whatever transformations we applied to the random variable x get applied to the mean of the random variable x to get the new mean for the random variable y. As you know, adding or subtracting constants from a random variable simply shift the random variable and have no impact on variability. So adding and subtracting have no impact on the standard deviation. What does have an impact is multiplying a random variable by some constant. So to get the new standard deviation, if we multiply the old random variable x by a constant b and b is greater than or equal to 0, we will get the new standard deviation for the random variable y. However, if b is negative, we cannot have negative standard deviations. It doesn't make sense. So we take the absolute value of b and multiply by the standard deviation of the old random variable x. So what we're going to do in activity 6.2b is not only talk about transformations of the random variables x and y that represent our two scenarios for Jensen's Jeep tours and Orrich's explorations. We are going to talk about linear transformations of them and combinations of them. So let's get started. As you recall from activity 6.2a, x represents the number of passengers for Jensen's Jeep tours and y represents the number of passengers for Orrich's adventures. Their corresponding probabilities are given in the tables. What we're going to do is we are going to take a look at the distribution of the total of the two random variables. In other words, we're going to look at all possible combinations of outcomes for the random variable y and the random variable x, and we're going to find their sum based on the given probabilities. So, for example, the random variable x with an outcome of 2 has a probability of 0.15. The random variable y with an outcome of 2 has a probability of 0.3. That would result in a total of 4. And since we're going to assume these two random variables are independent, the probability of an outcome of 2 for x and a 2 for y, we just multiply the two probabilities, 0.15 times 0.3, and we get 0.045. There are lots of possible combinations of these outcomes that result in different totals, as you can see in this table. So what I'd like you to do for now is take a look at the ones that are filled in for you. When you understand how that's working, pause the video and find the ones that aren't filled in for you. In other words, find the probabilities of those particular outcomes, like, for example, a 2 for x and a 5 for y, which results in a 7 for a total. So hopefully you found the following probabilities shown in red, which are 0.015 for that particular outcome of a total of 7, 0.025 for that particular outcome of a total of 8, and 0.02 for that particular outcome of a total of 10. What we're going to do now is we're going to take a look at all of these totals and group them together. In other words, outcome of 4 only occurs one way. It has a probability of 0.045. An outcome of 5 occurs this way, and that would have a total probability of 0.060 plus 0.075. And an outcome of 6 would be this way, and this way, and this way, and so on. And 7 would happen all these ways. And so what I'd like you to do now is total up all the probabilities for the various outcomes of 4, 5, 6, 7, 8, 9, and 10, and use that to fill in the table on the next page. Once you have filled in this table, you should be able to do a few things. For example, t is a new random variable represented as the sum of the two random variables x and y. And based on the properties of random variables, you should be able to verify that the sum of all the probabilities of all the outcomes is equal to 1. You should be able to make a histogram of that random variable, and then you should be able to use the formulas for finding the mean and the standard deviation and the variance of the new random variable to find the mean, the standard deviation of the new random variable t. So go ahead and do that, and then take a look at letter H and compare those to the mean, the standard deviation, and the variance of the random variables x and y, and see if you can find a connection. So when you're finished filling out the probability distribution table, it should look like this. The histogram should look like this, and you should be able to find the mean, the standard deviation, and the variance of the random variable t, and they should be the same as those shown here. And the connection is this: the mean of the new random variable t is the sum of the means of the two random variables x and y, which kind of makes sense. This one maybe doesn't make quite as much sense, but the variance of the random variable t is equal to the sum of the variances of the random variables x and y, which means the standard deviation of the random variable t is the square root of the sum of the variances of the random variables x and y. I like to call this the Pythagorean theorem of statistics. So to summarize what we just found with this example, it is that if we have any two random variables x and y, and we add those two random variables to form a third random variable t, the expected value, or the mean of the random variable t, is the sum of the means of the two random variables x and y. We can extend this to as many random variables as we want. In other words, if we added 10 random variables to get a new random variable, the mean of the new random variable would be the sum of the means of the previous 10 random variables. As far as the variance is concerned, we add variances when the random variables are independent. If they are not independent, these formulas do not work. So to find the standard deviation, we have to add the variances of independent random variables and then take the square root of those. So I'd like you to pause the video for a minute and try problem 3 below. Now that you're done with problem 3 below, you should find that the mean of t, the total score, is equal to the sum of the means of the two parts of the math and reading, or 1026. And you should also find that it is not reasonable to compute the standard deviation or the variance of t, because it's not reasonable to assume that the two scores for an individual are independent of each other. The next thing we're going to do is we're going to look at the combination of two random variables that have been transformed by multiplying them by a constant. And as you recall, x is the random variable, the number of passengers that showed up for Jensen's Jeep tours, and these are the mean and the standard deviation of x. Y are the number of passengers that showed up for Orich's adventures, and these are the means and the standard deviations of those. And C is the amount of money that Jensen collected, and C has a mean here and a standard deviation here. Let's create another random variable, and that is the amount of money that Orich collects for his adventures, and let's say he charges $175 per passenger for his trip. So the random variable G, the amount of money that he collects, is 175 times the number of passengers that show up. So pause the video for a minute and find the mean and the variance and the standard deviation of the random variable G. So the relationship between the mean of the random variable G and the mean of the random variable Y is the mean of the random variable G is simply 175 times the mean of the random variable Y. The relationship between the standard deviations is that the standard deviation of the random variable G is 175 times the standard deviation of the random variable Y. And since variances are standard deviation squared, we just take the standard deviation 175 sigma y and we square it, which is 175 squared times sigma y squared. The last thing that I want you to do with this example is find the mean and the standard deviation of the total amount that Jensen and Orich collect on a randomly chosen day. So essentially what we're doing is we're creating another random variable, which is C plus G. So use that to find the mean and the standard deviation of the total amount Jensen and Orich collect on a randomly chosen day. So what you should have found is that the mean for the total collected is $1,105 and the standard deviation is $232.30. Again, we can add the means and we can add the variances of the random variables C and G because we have assumed that the two are independent of each other. In the last example that I want to do here, it addresses adding random variables and how that is not the same as adding variables algebraically. So we're going to start out with the random variable x, and it's the amount gained on a single $1 bet on red when playing roulette. Turns out that the expected payoff is -5 cents and the standard deviation is $1. What we're interested in is a player's total gain over 2 rounds, so we're going to define x1 as the amount of gains from the first round and x2 as the amount of gains from the second round. Then the total payoff would be x1 plus x2. x1 and x2 have the same probability distribution and therefore the same mean, so we're going to find the new mean, mu t, is equal to mu of x1 plus mu of x2, which is equal to -0.05 plus -0.05, which is -10 cents. The next thing we want to do is we want to find the standard deviation of this random variable. Are the two variables independent? Well, it's plays on a roulette wheel, so yes they are, and so the standard deviation of t is going to be equal to the square root of the sum of the variances of x1 and x2, which happen to be equal to each other. Well, the variances are both the standard deviation squared, so that's the square root of 1 squared plus 1 squared, which is equal to the square root of 2, which is approximately 1.414. The question that often gets asked is, what is the mean and the standard deviation for the random variable 2x? Now, what you have to be clear about is that 2x is taking the outcome on one round and doubling it, compared to x1 plus x2, which is taking the outcome on one round and adding it to the outcome on a second round. So 2x would be a $2 bet, and then we would have a new random variable, 2 times x. And from our rules for means, our mean of 2x would be equal to 2 times the mean of x1 or x2, which is equal to 2 times negative 0.05, which is equal to negative 10 cents. However, the standard deviation is what we really want to take a close look at. The standard deviation of 2x is going to be equal to 2 times the standard deviation of x, which is equal to $2. That is not the same as the standard deviation of x1 plus x2. And that is often very confusing for people. And the example that I like to use for that is the following. Think about playing a game that uses 2 dice, and think about losing one of those dice. So in the one situation, you're able to play a game which is the sum of the 2 dice that you roll. And as you know, that can have outcomes anywhere from 2 to 12. An outcome of 2 can only occur one way. An outcome of 12 can only occur one way. But for example, if you had a sum of, let's say, 6, that could happen several ways. Well, what if you lost one of those dies, and instead of taking the sum of 2 dice, you doubled the outcome on a single die? Think about the possible outcomes and the probabilities associated with those, and think about the shape of those distributions and whether or not those shapes would be the same, and whether or not those standard deviations for those random variables would be the same. They would not. So what I'm saying here is that algebraically x plus x is 2x, but when it comes to combining random variables, x plus x is not equal to 2x. To make sure that you fully understand the concepts from this video, I'd like you to take a moment, pause the video, and do this check your understanding problem, and then check your answers before you finish. So these are the answers to the check your understanding problem. Please pause the video, read through the answers to these, make sure that you understand them, and if you don't, make sure that you ask your teacher the next time you have class with them.